bj, and let's say which of these ascending runs that belongs to. So let's say that belongs to the nth ascending run. And by nth, I mean starting with 1 on the left. So this is 1, 2, 3. So then this index bj has to be L plus j. So it's the jth position from the left that isn't one of the a's. But if we're in the nth ascending run, then L of these positions have a's in them. So our position bj is equal to L plus j. So we're certainly going to have a new descent at position L plus j, and then how many descents to the right are going to get moved up by 1. So there's k plus 1 minus L ascending runs to the right. And each one of those ascending runs begins with a descent. So therefore, the insertion of I into position bj creates a new descent I think I said a position bj before, but if we're inserting a new letter, it's really the previous position that counts as a descent, because it's going to be that position of the larger letter followed by this new small letter. So it creates a new descent at position bj minus 1. Now we already know how to increase the major index by 0 through k, which I just erased. So we're hoping to increase the major index by k plus 1 through n minus I, all of the bigger increases. So we've got a new descent at position bj minus 1, which is L plus j minus 1. And then we're pushing k plus 1 minus L descents 1 position to the right. So we push k plus 1 minus L descents 1 position to the right each. So then this increases the major index by let's see, the new descent was L plus j minus 1. And then we push k plus 1 minus L This is the number of descents increased by 1. So that's the change in major index, and I guess the L's cancel, and the -1 and the +1 cancel. So what does that leave us? J plus K. Now, J was the index of the B, and let's see, I erased how many of those there were. The B's went from 1 to n minus 1 minus K. So that means that the increase ranges from K plus 1 up to K plus n minus 1 minus K. So that's n minus 1. We actually wanted I. Oh, this is an I minus K. J goes from 1 to n minus I minus K. So K plus n minus I minus K is just n minus I. So we showed that the n minus I plus 1 ways to insert the letter I lead to increases of 0 to n minus I, which is all the possible values that we want to have in that position. So therefore we do have a bijection, and the conclusion is, well, that's the end of the proof. The conclusion is that major index and inversions are equally distributed on Sn for all n. The end.